Okay, so we've talked about distance in R2, Pythagorean theorem, dot product. We haven't totally generalized things, but we're about to by doing some easy proofs. And we're also going to talk about angles in Rn, and we have a better understanding of what magnitude of u or magnitude of v or u dot v would look like. They're just all going to be numbers, so you can calculate the value of this fraction, take the inverse cosine, and give you the angle between the vectors. Now, we're going to do some proofs, so we want a notation for a typical vector. So if v is the typical vector, one way to notate it is as a column vector. I could write it in a column, or we could write it in a row with semicolons, right? So I could have written it as a column vector, but I didn't have a lot of room for a column. That would have been an equally good representation. But usually for space, we're going to write things out in rows. Or just, parentheses, v1, v2 through vn. If this is real Euclidean space, Rn, then this is what we mean by a vector. It's just an ordered set of n numbers. And if we want, we can write it out as a row vector with commas. Or we could even write it out as a row vector without commas. Although this would be easy to confuse with what we would have if we had arrows over these, which would be a matrix of column vectors, right? So I'm usually not going to do this one. I'm usually going to be careful to use commas or semicolons, depending on how I want to write it. Okay? So, just as a starter, how would you write out the general vector u in Rn, the magnitude of the general vector u in Rn? What would you write out? Okay. Well, hopefully you've stopped and written it out. If you haven't, have you at least written out the vector u? Showed you. Okay? Well, do that, and hopefully you have, because I'm going on. Well, u, lots of ways you can write it. Now, I'm going to stick with bracket notation. Okay? But I'll also say, okay, this, or we could write it as u1 semicolon u2 semicolon un, which would be column vector, right? Okay? Now, in terms of this representation of u, how are you going to write out the length of u, or the magnitude of u, depending on how you want to read that symbol? It's okay either way, as long as you're in Rn. Well, hopefully you've done that. If you haven't, pause and do it. But so magnitude of u is the square root of u dot u. And what's that equal? Well, I'll go ahead, it's u1, u2 up through un multiplied by the column vector, and I'm going to write the column vector with semicolons as a row. And there we have it. So you just match up first element, second, and so forth. And that's going to be the square root of u1 squared plus u2 squared plus un squared. If n is 2, then it cuts off at n equals 2. You just have u1 squared plus u2 squared, the I component squared plus the j component squared. If it's in a 47-dimensional space, well, you'd use dots, and you'd write u47 squared. So you'd have all the u1 through u47, each one squared, and add it up. Okay? Okay, well, let's see. How about this? How about distance between V and W. Can you write that out? Or if you're on top of this, can you just think and visualize what you would have? Okay, well, hopefully you paused and done that. Hopefully, if you're smart enough, you didn't even have to pause, you saw it immediately. But that's just, well, actually, there's no U in here. W. And that's what? Well, if you use notation, and the notation's going to be implicit, actually, no, I'm going to add a couple more steps here. Hopefully you see what it would be, but I'm not going to assume that. So if you do, yeah, skip ahead a little bit and see if you're right. Okay, this is what? Well, first of all, use brackets. W1 through Wn minus V1 through Vn. Okay? So, we've written down the components of the W vector, the components of the V vector. Okay, how do you then write the difference of these? Write it out. Before I do, pause if necessary. Well, that's just going to be W1 minus V1, W2 minus V2, up to Wn minus Vn. Okay? Now, hopefully you got that before I did, but whether you did or not, let's see, what's the next step? Okay? And what's the step after that, if necessary? What is your final expression going to be? Because I'm going to skip to the final expression. I'm just going to point out a couple of things to show where that comes from. Okay, well, this equals, and what you would want to write out is this dotted with its, or this as a row multiplied by the same thing as a column. And when you do that, if you're used to the dot product, it's going to be pretty obvious that this is going to, well, it's going to end up as the square root of W1 minus V1 squared plus W2 minus V2 squared plus up to Wn minus Vn squared. Okay. Now your intermediate step, if you needed to write it, would be write this dotted with the same thing with semicolons. So you see it as a column vector. If you got room in your paper, you could even write out the row and the column. It doesn't take that much room. And then you see when you do the dot product that this is what you get. And of course you write it out as the square root of the dot product and so forth, and this is what you get in any case. So that's how you would denote the distance between two vectors. See how time's doing here. Okay, so we'll go on in a minute.